Hi everyone, welcome to this first discussion of the week one of COGS118B. Uh, so this quarter we're going to do stuff a little bit differently. We are going to pre-record those discussion videos, and uh, in those videos I will go through some practices and some notebook demonstration. So in the section you will come to the section, and either you can watch this video in the section or before you come into the section. So we TAs and IA will be presented in the assigned room, and then we will be here to answer any question you might have interactively. So in this way, we avoided to repeat ourselves several times of the ideas and dedicated more time to face-to-face interaction between you. So let's get started. Oh yes, and be sure to, in the anonymous feedback form, let us know whether you like this format, you dislike this format, whether you prefer this, or whether you prefer a more traditional lecture style discussion session. Let us know. Okay, let's jump right into it. So here is our COGS118B repositories. We will distribute our discussion notebooks and solution in this repository called discussion section, pinned in this page. So let's go to this page. So you see that we have week one information here. Click on week one. So what you need to do is to clone this repository down to your own computational platform and execute this notebook with me. And then whenever you get stuck and you have some question, feel free to directly see the solutions. We give the solution along with the questions. So yeah, so let's go to the notebooks. So one thing I want to say is in this video, I will walk you through every single questions of the notebooks. But however, it is highly recommended of you to do the notebook first, and I will mark sections of which question in this video. So if you find knowledge that is like, I know this very well, you could skip it to the point of where you get stuck. So I highly recommend you, if you haven't cloned this repository down, clone it and stop the video here and open the notebooks and do the notebooks before watching these videos. Okay, let's get into it. So yeah. So the first line we see here is initialize order. Whenever you see this error message, it is fine. If you find that particularly annoying, you could find a way to remove it, is to pip install, upgrade the expert. So now it's get updated. If you restart the kernel and delete this line, so now the warning disappear. So I think you have to do this for your homework, otherwise the export will not function. So yeah, so that's for this line. So in this quarter, we are using this type of Jupyter quiz, which is, you will find it pretty interesting. So this is an interactive quiz that allows you to click on each options, and it is not graded at all. You will see the correct answer as you click. We aim to provide those as supplemental material for you to understand the core course content without grading you, right? You get feedback right away. Okay, so let's jump into it. So the first question is, in the medical diagnosis algorithm, a false positive result means which of the four followings? So a false positive means that first, the false means that it is not true. It is a false prediction. It is incongruent with the realities. So the false means that our prediction is different from the realities. And positive is that focusing on my prediction. So my prediction is false and my prediction is positive. I found it particularly confusing at first when you have true and false and positive and negative. But I found it really helpful if I put it in another way of the false positive of a false prediction being positive. So those four options, let's see. The first option, the algorithm incorrectly identified a healthy patient as sick. So incorrectly correspond to false, but identified a healthy patient as sick, which means that it predicts positives. So this will be correct. So let's see other options. The second option is the patient condition is undetermined by the algorithm. So the algorithm haven't made any choices yet. So there isn't true and false because the algorithm haven't been made any choice. The third option is the algorithm missed a sick patient, identified them as healthy. So the first part, the algorithm missed a sick patient. That means that the algorithm is false, right? Its algorithm is false right now. But it identified them as healthy means that I made a negative mistakes. So this patient should be sick, but my algorithm predict them as negative. So it's an incongruent fact that the patient is sick, but my algorithm predict that they're not sick, they're healthy. So it's a false negative in this sense. So the final option is the algorithm correctly identify a patient as sick. So the correctly identify part correspond to a true. Correctly identify a patient as sick correspond to true positive. Okay. The second question is, if a spam detection algorithm is tweaked to be more sensitive to detecting spam, i.e. the probability of the tweak algorithm of predicting a spam is larger than the probability of the original algorithm of predicting some email to be a spam on the same data set, which is likely to increase. So think for a second. Our newer algorithm is able to, it will flag more spam, and as a result, it will make more positives overall, right? Regardless of whether they're true or false. So the answer will be true positive and false positive. So it will lead to more true positive, as it might correct itself from the previous mistakes. But more importantly, it will make more false positive because if our data set has more spam, overall has a smaller portion of spam compared with not spam, when the algorithm predict more spam, it will make more mistake on false positive because there are more emails that is not spam in our data set. Okay, so let's go to the next question. So if we have two, if you have PA equals to 0.5, PB equals to 0.3, and PAB equals to 0.15, what is PA given B? So we know that, okay, let me stop it. All right, for this question, we know from our formula as P A given B times P B equals to P A and B, right? So in this case, we could tweak things around. So for move the P equals to B, PB into the right hand side. So we have PA given B equals to PAB divided by PB equals to 0.15 divided by 0.3. So we will have 1/2. So the answer here is 1/2. So for the next question, a bag containing 3 balls and 3 red balls and 2 blue balls. If 2 balls are drawn randomly without replacement, what is the probability of both are being red? So in total, we will have 5 balls, and so 2 of them will be blue, and 3 of them will be red. And this is our bag. So what is the probability of the first time when I draw the ball if it's a red ball? So there are 3 balls that are red out of 5 balls. So the probability is 3 out of 5. So let's say we took 1 ball already out. Now we only have 4 balls in our bags. So the next probability of picking up red balls is 4, 2/4. So the answer will be, those times together will be, this is 1/2, 10/3. So it's 3/10. Yes. So the next question. So the next question is, if a discrete random variable x has the following probability mass function, what is the expected value of the x? So the definition of the expected value of a discrete random variable is, so E of x is equal to the sum of all x times px. So what does that mean is, for each value of x, we time the probability mass and then times the x value of that probabilities. So let's fill that in. It will be equals to 1 times 0.2 plus 2 times 0.3 plus 3 times 0.05. It will be 0.2 plus 0.6 plus 1.5 is equal to 2.3. That's 2.3. Correct. So the definition of an expected value for a continuous random variable is integral of -infinity to infinity x dx x px dx. So in this case, we have a random variable of y that is only defined in the interval of 0 through 1. So what we'll see of the probability function, density function, will be something like this. This is x, this is y. Actually, this is y, and this is py. And here is 0, here is 1. And we have something like this. Here is 2. And we have 0 everywhere else. So effectively, our integral is only non-zero from 0 to 1. So we could simplify that function to the integral from 0 to 1 of 2y times y dy. And we calculate that as 2y squared, and we take the integral of that as, it's been a while, it's 3 over 2 y 3 to the y cube 1 0. So that's 2 over 3 minus 0, so it's 2 over 3. It's 2 over 3. Yeah. All right, so that's for the math stuff. So now let's go back to a little bit of introduction of NumPy. Okay, let me change back to the whole screen and turn off my iPad. Okay, so for NumPy, so first and foremost is import NumPy as NP, as always. So there are multiple ways to create NumPy array. So most direct one is directly call np.array and fitting with a parenthesis and fitting the value of the array. So for now it's 1 and 2 and 3. This is one dimensional, but if I want to do two-dimensional array, meaning which is a transpose of the array underscore 1D, I could hard code it as so this is the outer array, and this is inner array. This is the second dimension, and 3. So the one-dimensional array has a shape of 3, a comma. There isn't the second element of the shape, which is indicate that this array is one-dimensional. And for two-dimensional array, this has a shape of 3, 1. So the shape has 2 dimensions, so it's a two-dimensional array. So I want to, from here, we could also do array 1D dot t, which stands for transpose. Oh, actually, there isn't transpose for one-dimensional array. There is a transpose for the two-dimensional array. So the concept of transpose only exists as a matrix. So we could flip that 1, 3 shape of 1, 3 two-dimensional array with dot t. We now have a two-dimensional array also, but with a shape 1 and 3 instead of 3, 1. So we could check that. So the shape of this two-dimensional array is 1, 3. Okay. So given a 3 by 3 matrix, extract the second row of the matrix M. So now we use the M, call the matrix, and then we use a square bracket. So NumPy index works on multiple levels. So because we have a two-dimensional array, we could do 2 indexer in the square bracket. So it starts from a row and a column. So the second row is 1. So it's 4, 3, 6. So NumPy is 0 indexing, of course. So the second row is indicated by M1. This is also equivalent of 1 comma and column. So column is a wildcard. Will catch every single row, every single column. So because this is the second indexer. The first indexer for row and second indexer for columns. So now we have the second row indexed by 1 and then comma. This will yield the same results. So so the second part is asking the third column on the column from the matrix M. We'll see that. So now we need every columns. We need every rows. Excuse me. So the first indexer we put comma here. We put a colon here, and then we comma and do -1 or 2. So the first indexer is for row, and the second indexer is for columns. So now we have 3, 6, 9, which is the third columns of the matrix row. So we want to extract the element in the first row and the third column. We do first row 0, third column 2. Yeah. So now modify array in place. So I guess, the question is here. The given matrix M, modify the first row of to 100, 100, 100. So, because Python is the matrix of NumPy is non-primitive, it's referencing by address. So you could do a lot of change in place. And NumPy matrix is NumPy variable are mutables. So we could do we could do something like this. The first row, which is indexed by M square 0, get everything in the first row. Just to be safe, we could also do the colon for the column indexer. And we could assign value directly to this matrix. So we could do, we index that list out, and we equal sign to 100 to broadcast 100 to every single element in that row. So let's see what will happen. So this line of code effectively modify the first row to 100. So the second is for the last column. So by the same token, we could do column, comma, -1 equals to 100. So this is happening behind the scene. It index out that columns and broadcast the value of 100 to every single element in that columns. And we could also do math operation on this by directly times 3. We effectively times 3 of those NumPy array. And this is broadcasting, because we are only broadcasting one element to every single element in the array, in the matrix. So we could do times to broadcast it. And there are more ways to do stuff. So element-wise sum, you could do plus, difference to minus, products to do an asterisk, and division do a slash, and comparison with double equal sign. So you'll see how the output is as desired. And we can also do some summary statistics on stuff. So we could do the sum, np.sum with this array. Directly with the array itself, calculates the sum of all elements if we don't specify an index. So if we want to sum of each column, we do x is equal to 0. If we want to sum along each sum of each row, we do x is equal to 1. And this part is quite important as matrix operation. Given two matrices, usually later in the course you will use a lot of this. So there are several ways NumPy allows you to multiply two matrices together. So one way to do it is to do A at B. The other way to do it is to do A dot B. Both of them yield the same results, but I personally prefer the at. It's just shorter, works like charm. So AX, like A at X, will multiply a matrix with a vector. Okay, so let's actually play with load some data set into a NumPy array and to see it. So the function of NumPy loading dataset into NumPy is to np.load txt with the string of the file directories. Oh, typo. And now we see that the iris.txt under the folder data has been loaded as a matrix that allows us to play around with. So we could do something like iris dataset.shape, and we could see that how many rows and columns we have. Okay, last but not least, we have some matplotlib practice. So first we import PLTs, and we need to plot a sine function of the domain of this, -2π to 2π. So if we want to plot a function, we need to define a linear space of x-axis first. So we could do x equals to np.linear space -2 times np.pi 2 times np.pi. The third variable, the third is the step. So we could float object cannot be interpreted as an integer. Am I doing this wrong? No, okay. The first, you need to pass into the linear space as a interval, as a list. So we will see that we start from -3.28 all the way to, yeah. I'm sorry. Give me 1 sec. Okay, I'm sorry. I just checked the documentation for a linear space. So it is start and stop with the number of stop specified. So this is not should not be in float. It should be an integer. So let's say we want 200 points. So we have 200 points from -2π to 2π. And then for y value, because our x value is already an np array, we could do np.assign x, y. So we could do plt.plot x and y. It will effectively plot the sine function for you. Okay, so this is the end of the discussion 1 notebooks. So if you have any questions, feel free. If you are in person right now in the CSB 114 or which room, I forgot. If you have questions, feel free to come out to me. Or if you're watching this at home, feel free to make a Campus Wire post, and we were happy to help. Peace.